we've got about just about everyone here. So thank you all for coming out. This is an incredible crowd. I was chatting with a coworker of mine the other day who's out in the Bay Area, San Francisco, and I told her that I was hosting a AI-related event in Chicago, and she kind of laughed a little bit. She was like, "You really think you can get that many people to come out to like an AI event in Chicago since it's not such a tech city?" And I was just like, "This is great." We actually had, we have space in this room for 120 people. We had over 300 sign up to come. So this is just amazing. So give yourselves a round of applause. This is awesome. So welcome to the CrewAI Enterprise AI Agent Week for Chicago. So for those who don't know, this is actually a global event that's happening it's being put on by CrewAI. So what Crew is this is a company that builds a multi-agent framework that allows enterprises and other organizations to essentially build AI agent systems to automate their operations and things like that. And this is actually CrewAI is the leading AI agent framework, and they're putting this event on across all whole world, a bunch of different cities. The main event is in New York. We volunteered to do the Chicago version of the event. And so this is a collaborative between my newsletter, Building AI Agents, and GenAI Collective. And so you'll hear a little bit more about them in a second. But first we're going to do some quick intros. You'll hear from Michael Schuler of Cloudera, who's going to talk about essentially, what is CrewAI? How do you build agent systems with Crew? You hear from Jack Blandin, who's the founder of Lambda, which is an AI-powered recruiting platform. And you hear from him about how you can actually enhance your agents with using reinforcement learning. We'll have another quick food and drink break so you can continue to enjoy the great food and beverages that we put out. And then we'll hear from Quentin Reul, who's going to talk actually about how you can build agents using Microsoft Copilot and 360, which is obviously very relevant given where we are. We'll have a panel discussion where you'll hear from really some people from not only the leading companies in Chicago, but all across the world, who are going to talk about, what are they doing at their companies with agents? What is the future of the technology? And then at the end, we'll have some more time to network, finish off food, meet some great people. So it'll be a great night. I want to give a special thank you to all of our sponsors. Thank you to Microsoft for providing us with this space. Thank you to Cloudera also for sponsoring the event. And thank you to my newsletter, Building AI Agents. So please give all of our sponsors a round of applause. So for those of you who haven't met me, I'm Michael Cunningham. By day, I work as a machine learning engineer at AbbVie, which is one of the biggest pharmaceutical companies in the world, and it's based out of Chicago. But outside of that, I am the founder and writer at Building AI Agents, which is a bi-weekly newsletter about developments in the AI agent space. So essentially what this is I put out a newsletter every Sunday and Thursday, and what we're covering is news, useful tools, courses, basically anything related to AI agents that builders in the space might find useful, or business leaders who are interested in bringing this technology to their companies, because it's one of the hottest technologies right now. Everyone's talking about AI agents. I'm sure you all know that's why you're here. And so really what we try to do at Building AI Agents is kind of cut through a lot of the hype, the spam, all of kind of the empty promises of a lot of the AI media that you see where it's just clickbait. We're really trying to bring true quality news to professionals that they can use to enhance their work. And so as a result, we're growing like crazy. We have over 2,500 subscribers, growing very fast. And we really are attracting, I would say, that very high quality audience that we want. We have a lot of startup founders. We have executives from major companies, business leaders. That's over half our audience. We also have a huge contingent of builders, software engineers, people who are actually building the technology that we're talking about. And so I definitely encourage you, whether you are new to this space and just getting started, want to learn about AI agents, or if you are an experienced professional in the area, again, business leader looking to bring this to your company, or if you are a builder who's actually building these agents, wants to learn what tools are going to help you out, definitely encourage you to subscribe. I know that it will be valuable to you. And the reason I keep saying we when I talk about this newsletter is this is actually not just my newsletter, my project. This is sort of collaboration between myself and my friend Akshay Patel, who is he is really the building AI agent side of building AI agents. So I write this newsletter, but what he's actually doing is he has an agency where he is building agents for businesses that need these for their operations, and they're getting just a tremendous amount of value from it. So if you're a business leader where you think that this might be a technology that you want to bring to your company, definitely talk to Akshay, and he can build AI agents for you. But before you hear from Akshay, you're going to hear from Mary Grugleski. So Mary is, I call her the undisputed queen of the Chicago AI meetup scene. Yeah, give Mary a round of applause. When I decided I wanted to do this event, I knew that there was just one person I wanted to talk to, and that's Mary. So
thank you so much. Yes, Michael. Yeah, Michael is the one that knew about the CrewAI asking for a call for proposal to run an event in the local chapter or local cities. And so when he approached me, I thought, well, I actually have to tell you, last week I was also speaking at a conference in Michigan, and I got back only one day, then I had to go to Austin, Texas for Dr. Ankatz, if you're in the Java community. He's still actually running that conference. So I was just there, and I came back, and I was trying to do this. So, but the thing is, I have to say, it was kind of really nice. My first time collaborating with Michael and with Akshay, and also too with this event, I'm also representing GenAI Collective. It is a new organization, new chapter here in Chicago, and the GenAI Collective started off in San Jose. But I guess before we get into that, and I will introduce you to Jonathan, but wanting to just quick kind of intro of AI agents. And how many of you are already working with AI agents or actually building? Oh, so quite a number of you. That's very cool. And how many of you are coming here because you're curious, right, and learn stuff? Is that right? Yeah. So also a lot of you. So you are in here for a treat because, as Michael has already talked about, we're going to be talking a lot about AI agents, and that's what we are focusing on as such, right? With AI, Gen AI, what first came out was all the LLMs, and now I believe it is the agents is the next big thing within this space. And it's a lot of questions, a lot of things, a lot of possibilities in here too. It's going to help us to do more things autonomously, as you all know. So yeah, so we're all in here for a treat. So as such, I wanted to also tell you that Gen AI, let me go back to the Gen AI Collective, the Chicago chapter, just started in November. That's when I got an invite from Jonathan, who's the head of Chicago chapter, and it's such a wonderful community because it's not just like focusing on, say, just tech or VCs or startups or whatever business, but it's basically a community that brings together all aspects of folks trying to build and use together. So we are already really having a lot of fun with it. And again, I want to introduce to you Jonathan. He's been very instrumental in bringing the community together. I'm sitting at his house. He can look really good too. So here's Jonathan.
Thank you so much, Mary. And again, a round of applause for Mary. She has so much in the community. I think it's doing that's serving the case. She's made the GenAI Collective a very special place to be. So with that, I'll just keep this under a minute. The GenAI Collective started essentially as a space for folks who are from the business or the technical side who have questions about speaking a language with investors. It's an open environment for anyone who is touching AI. So I work at AWS, I work at Uber, I work at Smith's Group. I've used AI in a variety of contexts, and I'm always curious. I'm not technical myself, but I speak between the business and the developers. So it makes, thank you, Mary. I promise. Oh, thank you. So essentially, I like to get together with folks and host these events so that we can all learn from each other and we can ask our questions, get curious together, and find out all that technical information, or from the business perspective, or from the investor side. So with that, we host events every month, sometimes twice a month, sometimes at my home, sometimes at MBUB, spaces like this. So we invite you all, wherever you're from, and to invite your friends and colleagues, whether they're from the business or from the technical side. I promise to keep it short, so thank you so much. Thank you to everyone for making this possible. We appreciate it. Back to you, Karen.
Because now we want to also thank our venue sponsor. When I was searching for a space, I knew I could reach out to David, and he's always been such a great help here, especially to helping with the Java users group. So if you're also Java developers or JVM, please also consider joining my meetup too. I'm also there. But for now, let me welcome or actually have David come out to say a few words, and really thank you so much for helping us with this venue, this beautiful venue. So,
Thank you, Mary. I hope you don't mind. I brought my friend Kevin with
yes,
me.
please do.
Kevin and I are on the partner team here at Microsoft. Our job is to, we're technical architects, and our job is to help people build applications for Microsoft Azure. As you probably heard, Microsoft is very much invested in AI from agents that we've built. We've got a whole series of them called Copilot. We've got developer tools. You can write your own agents in your own AI tools in Python and C# and Java, just about any language you want. We've got things that are hosted in Azure, lots of services that are available. So if you want to hear more about these things, we're heavily invested, largely in part with through our strong partnership with OpenAI. And I want to welcome you all to Microsoft. Thanks for that.
Hello, everyone. How many people have been here to the Technology Center, or now called the Innovation Hub before? So welcome back, and welcome to those who are new here. As you think about technology changing so much over the years, even the fact that we used to have a data center on this floor, but now it's a conference room. Technology has changed a lot over the years, but really the mission of this facility is ultimately the same, which is to help people understand how to solve problems using technology. And we have some exciting technologies these days with AI and agents and things like that. So I think we're all in the right space to learn and build some community. So thank you for being here today.
Hi, I'm Patel. Michael mentioned me earlier. I help run the Building AI Agents agency. It's funny enough that we run an agency and or we have a newsletter and it also builds agents. It's funny, the name is the same. Sorry, I'm just scrolling through the slides. Here we go. So a little about the Building AI Agent agency. We build custom AI agents for enterprise companies. Now you're thinking, why would I want this for myself? There's a lot of DIY, off-the-shelf AI agent marketplaces. So I encourage all of you guys, if you don't have a company or don't want to bring AI agents to your company, explore them. There's a lot of great agents out there that you just take off the shelf. But if you need something a little more customized, agencies like ours are really great. We find building agents around teams are more effective than teams around agents. Keep the system in mind, and you don't have to change the business of that entirely. The agent should work for you. So with that, we try and keep agents and humans together. We see agents as productivity boosts where your team can go further than just replace them. I know the common thing you see on social media is I'm going to replace my whole team with AI agents. We don't really see that as the case. We see this as more of a productivity enhancement. And so we build agents that are based off outcomes. The more specific you can make agents, the better they perform. So making an agent that directly deals with customer service, sales, marketing, you'll get a more predictable outcome. So one client we're currently working with is a UK-based media ad sales agency, and they basically go and sell ad slots for other companies that just aren't great at doing ad sales. And they've approached us and said, hey, our team spends a lot of time selling ads, and their sales team is swamped with just incoming leads. So what we partnered with them to do is just set up an SDR agent, sales development assistant agent, that will qualify leads, so basically understand buying intent signals. They will then go and enrich those sales leads data, so go straight to their LinkedIn, their newsletter, website, anything that they have kind of tied to their company, and then package that very nicely for the sales team, and then gets people to book a call. So this is where then the sales team can kind of do what they're best at, sell. The agent handles all the upfront work, all the admin work, 70–80% of the time, stuff that would take hours for a sales team to kind of go out and research is now kind of packaged, ready to go, and the sales team can kind of just sell. So it's helped them bring their sales team a lot further in a world where people are just very, very expensive. People are looking to go offshore. This helps spread US based clients further and further. So you can take your US team, somebody that you have to probably ship offshore, and you can now kind of afford to keep these people in here, empowering them with agents and just making their work go further. So if you're interested on learning more about building AI agents or bringing them to your company, hit me up. Our other developer over there in the front, Michael Zuby, is our other developer. So he helps us build agents, and he's doing a really good job with this one. So thank you. Before I get off here, I was gonna kick off our next speaker, Michael Schuler. He's joining us from Cloudera, one of our wonderful sponsors. He's gonna go through a demo where he talks a little bit about AI agents, Crew, and Cloudera. So everyone give Michael Schuler a warm welcome.
Thank you. Like was said, my name is Mike Schuler. I'm with Cloudera. I'm a business solution architect. So, um, there we go. So my job is mostly around outcome-based solutions. So what is it customers in different verticals are trying to do, and how can we help solve that problem with Cloudera? Obviously, since we're working with CrewAI here, the focus is more around AI agents and being able to provide those agents with data that makes sense for them. So what we're going to look at here is a little bit of an introduction to agentic AI. We'll talk a little bit about Cloudera's ecosystem and the AI use case for oil and gas, and then a little bit about the partnership, and then we'll leave some time for Q&A, hopefully. So just a quick overview here. So obviously, 2022, ChatGPT kind of jumped on the scene, made things exciting for a little bit there. And then it kind of grew from there, right? You had the early adopters, people who were going out and figuring out how to spin this up with Llama on their local laptop, small models, and be able to start querying and building things, and then finding out that to run a 160, 180 billion parameter LLM on their top is probably not going to be a thing. So then it sort of grew, and now it's in production, and now we've got to the stage where just talking to the LLM is not enough. It's about the context and how we word what we're doing. So the nice thing here with agents is as simple as this. So if I ask an LLM, what is Cloudera AI? If it's a RAG model, it can figure that out pretty easily. Down a little further here. But if I were to ask it to do something that required context, like actually building a Cloudera AI workbench, it's not have any clue because there's no documentation around it. There's nothing for it to enhance that response to actually build what it needs to there. That's where the agents come in. So now the agent sits in between the user and the LLM and is able to access its tools, grab data from different sources, and start to apply context to that. So with CrewAI, you can have that master agent that controls the flow, and then you can have multiple agents under that that each looks at the response and then modifies the response that will give back to the user to be more contextually aware or accurate. One of my favorite things about this sort of flow is that if you're doing any sort of debugging with it, every once in a while it'll catch it sending itself an email, which is a level of meta that I find hilarious to a certain degree then. But again, because these tools are specific to a use case, we can make sure that they're accessing the data in the way that it's supposed to be via API calls, through the CAI workbench, and then also the tools around Cloudera that helps with these things. Being able to bring in data, provide it all in one location, and then make it specific. So obviously agents, they perform specific tasks, they're able to make decisions, they're able to communicate with each other through sending emails, which crazy. It is able to maintain a memory of those interactions and then delegate tasks where needed. So you can split the load up amongst multiple agents that do multiple things. So we'll go ahead and look at the Cloudera ecosystem here. So obviously, I don't know that data is the new oil anymore. I think it's always been the oil. It's more how large is the amount of data that I can put in one platform to actually make this useful. Obviously, companies are running out of data to train their models because people figured out that they were using copyrighted data, and well, if your copywritten data is in there, you're probably going to want to get paid for that. So that could be a bit of a challenge there. And then you've got regulations and trade secrets, all those things, being able to make sure that GDPR data stays in a GDPR state, HIPAA data is protected, encrypted, and not made available, and then also being able to host a model in a location that's closest to that data. So with Cloudera, we have an inference service that runs directly in our workbench, so not only can you build your AI workloads, but you can access a private model over an encrypted channel without having to send it out to Anthropic or OpenAI or anything like that, which again makes the data more secure and more beneficial to you. And then the support for open source. So Cloudera's big movement right now, or for as long as I've known, is they are a very open source forward company. They're major contributors to things like NiFi, Spark, Flink, and Ozone, and Iceberg as well. So a lot of big name technologies out there that we support from a tools perspective, but then also from a large language model as well. So again, we can control them, we provide the security, privacy, and the economies of utilization. So if you're not using something, we can scale it back, save money there, and then when you have a large demand, a lot of people are querying or bringing in a lot of data, quickly scale that up. So again, with Cloudera, the benefit here is it's a hybrid cloud solution. So we can host infrastructure on Azure and be able to provide a fast, easy place for you to spin up your data, train a brand new model, and then bring that back on-prem for hosting if you want to, or you leave it in the cloud and just do everything there. But again, with things like NiFi, Flink, and Kafka, we can bring that data in from IoT sources, APIs. There's over 458 connectors, and we'll talk about that a little bit more for NiFi. And then that open data lakehouse, things like Ozone, Iceberg, and Spark, where we can not only provide a file level or object level format with Ozone, but we can also put Iceberg on top of that, where you're able to write the data in and then query at mass scale from that data. There's some great videos out there from Bloomberg where they actually talk about how they're using Iceberg today and the benefits they've gotten out of that solution. And then lastly is the important part, the enterprise AI. So NVIDIA NIM support for our workbench, but also support for companies like Anthropic and OpenAI if you want to go out to an external LLM provider. And then lastly, CrewAI, the all-important piece for being able to do that agentic workflow. And then down on the bottom, you've got the unified data fabric. So with all of these tools and all the data that's stored everywhere, we can provide that single pane for security, governance, lineage, and observability. Lineage is probably one of the more important ones because just having data doesn't really give you enough to make a smarter LLM. You have to have context around that data. Where did it come from? What is the state of it? What does it look like from a catalog perspective? And then be able to see who's doing what with that data. Because we want to make sure that a group of engineers in Germany is not sharing their data accidentally with someone in the US or in another country, since they have specific rules around where that data can live. So being able to audit and monitor that gives us that ability to make sure that the data is in one place. Again, since it sits on both on-prem and public clouds. We can cover all the major providers on-prem and in the cloud, IBM, Dell.
He's grabbed one of those mics and turned it on. Actually work. It's probably easier than using the lapel mic. Is that still working? So I took the nice mic myself and I gave him the bad one. So my evil master plan worked. I see.
That's all good. All right, is that better? We're not getting as many squeakies. Great. All right, so we'll continue on here. So obviously we talked about all of these. So let's look at the Cloudera part of it a little bit better. So like I said, with data flow, we have that universal data movement where we can connect to over 450 types of data. It's a low code, no code interface. So it's basically boxes and windows. You can grab those, drag them around, make connections. Uniquely enough, Cloudera owned the developing company for NiFi before it was spun off. So originally it was built by the NSA. The team that built it spun off, started their own company, and that was purchased by Cloudera. So as far as support goes, we have a lot of deep knowledge around these tools to make sure that if you do get into a problem with what you're developing, we can get you fixed there and get you back up and running. And again, scalability to scale up and down as needed based off demand. So we have customers that can push over a petabyte a day in logs and other data from their edge endpoints all the way through to Splunk, using us for filtering, boring log files, and that sort of thing. So they're I'm not talking about it. All right, cool. Anyway, so yeah, with that architecture and the auto scaling, again, you can get a lot of data through it when you need to and save the money when you don't need to have massive scale. Then we've got the accelerated AI and ML deployments. So what we'll be looking at in the interface itself is what it takes to actually spin up an AI workload in Cloudera. And then we'll actually see a working AMP for intelligent maintenance as part of that. And then the bottom half, well, you've got the enterprise grade data lake, so we can go from small to massive scale for storage. As much storage as you can throw at us, it's there. And then be able to provide that security and metadata on top of it. So the data's there, you can secure it and make sure it's all protected. And again, we'll get some key differentiators here. So again, obviously you can read here, but we have those complete capabilities for a streaming platform. So being able to get large amounts of data into a single location. The tooling, so obviously open source is a big part of our solution, from security, performance, and admin overhead. And then being able to quickly and easily deploy standalone Kubernetes operators. So it is built on a Kubernetes solution, so it can scale. There's multiple ways to do that. And then it's obviously extensible, like all of NiFi is, with Python and JavaScript. And then the integration with data at rest. So being able to integrate with other data lake houses, Snowflake, we can connect to them, pull data from there, put it into an archive of data if they want, and then, bring it back to Snowflake when it's ready. And then just that ability to easily integrate with multiple solutions. And because we're supporting all those open source frameworks, it's easy to get in and start building. Most of the time, a lot of the amps I can build are agentic workflows I can build are pretty quick and easy within the solution. To write my code, put it to a GitHub repository, and I can pull it right from there into Cloudera and actually start using that application straight away. And then the tool. So we've got the data flow designer. So that is built on NiFi. So we've built it out so it's more clustered, and you can manage multiple data flows in a single UI, as opposed to where you spin up NiFi on your own. There's a single workflow there that you can use. You have to spin up multiple instances or switch out your workflow that you're working with. And then the stream messaging manager, this is built on Kafka, so we can be able to bring in that data and replicate it and write it to where we need to. And lastly is SQL Stream Builder. So we can actually have a UI that allows us to integrate with Flink and Flink SQL and start building data access and processing that data in a very quick fashion. So SDX, as I said, this is sort of our administrative layer, so it obviously can scale massively. We've got support for more than 2,000 plus users with self-service access to data. What that means is they can log in, and if they have rights to provision a virtual warehouse and have access to data, they can access that immediately without having to talk to someone in IT to give them access to the data. So group and ACL management is nice and easy. All you have to do is assign a user to a group that's associated with that virtual warehouse, and they can start using that data. Metrics, we track a significant amount of data points within the solution, so we can tell you where your compute is going, where your storage is going, who's using what, which GPUs are on all the time, and then that lineage-based scale, the ability to track data through the entire life cycle, and then also model metadata. So when you're training a new model, we can give you the lineage of it, who trained it, who made changes to it, and what else they need to monitor and protect their data. And then that reduces administrative overhead because you don't have to go to multiple solutions for data ingestion, your SQL data, and your storage. It can all be managed in one location, tagged, and user access is as simple as just adding them to groups. And then the virtual warehouse. So based off TPCDS benchmarking, we found that our virtual warehouse can be around 3 times faster. We've helped customers reduce their EMR from 11 hours to 3 hours, and then 40% better performance than Azure HD Insight. Auto scaling performance, again, because we're monitoring this, we can scale up when you need it and scale down. And then the scan performance optimization, where we actually have that ability to spin up additional agents or scanners to be able to reduce the amount of time it takes to actually scan that data when there is a significant amount of data there. So from an AI application lifecycle, on the left, you've got your raw data sources. So this would be anything from IoT hubs or individual devices, SCADA data. So in our demo, because we're looking at an agentic infrastructure model for oil and gas, there's SCADA data, there's a significant amount of IoT sensors from temperature, humidity to ground moisture that they're using to collect all this data. We can grab that with NiFi and data engineering, pull all that data in, do the ETL process, push that data to data products and data pipelines, and then that can be fed right into our AI tools. So we can place that on the infrastructure that needs to be, and then do all the processing. And then again, we've got SDX to, and I don't know why that says Dell, that's not supposed to say that. But anyways, then we've got the monitoring and cataloging. But then we can serve these up directly from the Cloudera AI workbench if we want, and then grab that data and send it back to our model to make it smarter for continuous learning. So for our use case, we are going to look at predictive maintenance. So the goal here is obviously we want to reduce costs. We want to make sure everything is operating efficiently. We want to make sure that we can expand on revenue because we've increased optimizations, we've reduced the amount of unexpected maintenance that we need to do, and we can get that back up and running quickly, or we can make sure that it doesn't fail at all, and then be able to use the information we're collecting from all these sites and build digital twins and other models to see where materials are failing the most and how we could potentially use alloys or other things to help reduce the wear and tear on these devices. So from an enhanced predictive maintenance, the challenges are on the left there. Obviously, extended downtime, knowledge gaps, and inconsistent repairs are the biggest challenges. So extended downtimes is money lost. If something's down, I'm not making money off it. I want to get it up as quick as possible. Knowledge gaps is always going to be a challenge because you've always got the senior guys that are impossible to find because they're probably off somewhere playing Clash of Clans or something like that. And they're leaving the younger guys with minimal experience trying to figure out how to solve these problems. So that leads to inconsistent repairs. When you've got a senior that's available and they fixed the problem, they fixed it, it's right, it works. The junior guys, well, they may not have known exactly what torque specs were for a specific bolt pattern. So the solution is obviously an agentic AI deployment. I can monitor all that infrastructure. I can provide repair information based off of the model of the pump or the infrastructure. So I can pull all the data from those hubs and get the model of the pump, the firmware version, all the things necessary to make a good decision, and then enhance that with their own support documentation and the documentation from the manufacturer of that device. And then I can optimize my resources to get the right person to the right location with the parts and the solution. So all they have to do is start plug and play. And then obviously we have a reduced downtime, consistent maintenance, since it's always going to be from the same documentation, the same instructions, and they just have to simply follow through the steps. And then obviously you're maximizing your knowledge repository because you're bringing it all into a single location. You know what you have, you know where it is, you can access it nice and easy. So from a little bit deeper diagram here, we've got our IoT data, we've got our other data like ERP, weather. It's all brought in either batch or streaming with data in motion. We're writing it out to the lakehouse, and then MLOps, model training and inference, can go ahead and grab that data and then send it back through to the lakehouse. Our agents, we've got our data collector who's going to start the process off. We're going to hand it off to the analyzer, the decision, the scheduler, and the communicator. So they're going to grab the data, they're going to analyze it, they're going to make a support decision as to, do I need to send someone out with a welder to patch a pipe, or do I need to send someone out who knows how to do rewiring for electrical connections? They can use the other data for unstructured repositories from SharePoint and other proprietary systems as well to feed that into your semi-structured data stores like your knowledge graph vector database, and again, enhance this process. And then on the bottom, we have the operational engineer monitoring and the web application that's doing all the work for them. So let's jump into the demo because that's way more fun. All right, so within my environment here, this is the Cloudera data platform. So data flow, this is where we'd go for those data flows, NiFi connections to pull data into the infrastructure. And then under Cloudera AI here is where I have my already built workbenches. So again, because we were talking about it a bit ago, we provide our own inference service. It supports NVIDIA NIMs. So I can come in here, pick any model that's self-hosted in my infrastructure, import that, create an endpoint, and plug that directly into my AI app. So I don't have to go out to OpenAI. I can use a nice model, open up. Llama 3.1 is there right now in my environment. If you really wanted to, you could go out and get Llama 3.3, get 180 billion parameters, and work a couple GPUs for it. So in my workbench here, we can go in and I can see all of the existing projects that have already been built. Get rid of that there. And then from there, well, let's take a look at that. So once you've spun up an AMP or an accelerated machine learning project, it's going to go through and it's going to create the container for you. So you're going to provide it with the instructions of, this is what I need to run for requirements. It'll run a pip process. It'll create the image for you and make that available for you through an application. So as we can see here, I just grabbed my GitHub repository for this. It pulls it down and brings it into my application. And then under applications here is where my application is at. And then all I have to click on this right here, and it brings up my application. So for this one, we'll go to the dashboard first. So I have 6 sites. I have 4 sites with 6 pumps and wells at each location. So I can pull the data quickly for the time period that's specified. And then from there, I can go to an AI analysis. So normally in an actual environment, you wouldn't want to have to click on this. It would run automatically, but for the purposes of checking it out, we're going to go ahead and do that. So I'm going to go ahead and click Run Site Analysis here. We're going to give it a couple minutes. Kidding, a couple seconds here. It's going to parse all the wells and sites for this specific site. It's going to do a deep analysis of all that information. It's going to come back with specific stats and recommendations for this specific site.
or is it already built and you use it?
So I have a fast API backend I built to actually generate the data. So all I have to do, this is already pre-built from code, so I just had to deploy it, and then I can start using it. But you could just as easily build it and do all that. So now let's come back to see if we do some performance analytics about Site 01. So we can see what the flow rate is for this site. It'll give us additional performance metrics around that location, and then I can either make decisions based off that, or the nice thing is here, it's going to automatically create the performance tickets for me. Again, you want this to be a automated process in your infrastructure, but for purposes of this, we can go in and not only can we see it's a low priority ticket, but what are the recommendations or what is it actually seeing that it needs to fix? Now, this is actually a really good example of why data matters. With this, it's just a fast API that's generating the data, sending it to the LLM, and it's getting a response. But it's a generic response because there's no contextual data in the data lake that would help make this more intelligent. Things like manuals or additional information on previous work tickets, so you could integrate your existing ticketing system into this and then be able to make it more intelligent and responses better. And again, it's a crew. It's not just a single agent, it's the orchestrator, and then it's got 3 different agents in there that allows it to look at the data from different levels and provide a better response for that. I talk fast, I apologize for that. Any questions or anything like that? Yeah.
AI analysis, is it like you have mentioned few KPIs and like it analyzes few KPIs and gives up, or like does it just broadly analyze the data and give whatever is the priority, like whatever is up to now and things?
So right now, the ones it's saying are low priority because the data it's generating was saying there's no major issues. But if it were to exceed a threshold or go below that threshold to a certain level, then it could create a high priority ticket. And it would normally do that, but it's apparently just feeling like everything's fine today, which is fine by me even. But yeah, no, basically you could enhance it in any way you wanted and be able to provide those metrics to get better response time. Yeah.
Do you have any like special tools doing this, or it's just give it to the
Yeah, no, so the only thing I had to build for this was the agents, obviously, and then the tools. So the tool that I had to build for this was to be able to pull the data from the repository it was in and then pass it into the vector database and then to the LLM to get my response. And again, with additional tools, we've got things like our RAG Studio that's coming out, and then our Agent Studio, where you'll be able to actually use a UI to actually lay out what your flow is and what tools those agents have. Yes, sir.
Do you have a process in this to evaluate the output of the agents?
Yeah, so in the agents themselves, you can set the context and what you want them to think about, and then the orchestrator will manage who talks to who and in what order, and then each can have their own tools for what data they want to pull into the conversation. Another one over here. Here, next one.
Thank you. What are you using for your knowledge graph, or are you using an out-of-the-box available solution?
Right now, I'm using an out-of-box solution from a partner of ours. It really depends on what you want to do with it. Neo4j has been a really good one for me personally, but they don't have a really great hosted solution for me yet that I can run in Cloudera. So if I wanted to do something that was more on-prem, so I wasn't sending the data off-site, I would have to look at something that ran in a container that I could spin up as part of my cluster to actually provide that.
One more question. And which vector DB are you using?
For this one, I was using Neo4j.
The
Oh, I'm sorry. This one's Pinecone.
Got it. Thank you.
I think we have time for 2 more questions.
Since the current approach has a lot of numerical data, is it fair to say that it might be prone to hallucination?
if you don't have enough data to provide the context, and that's part of what the crew should be doing, is evaluating the output that it's going to get back to you to try and reduce that hallucination. But obviously, there's still that chance of a hallucination if you don't have a purpose-built LLM for that. So like obviously with what I'm doing, because it's a general LLM, there's going to be hallucinations because it doesn't have it for context.
Yep. For the use cases you're seeing, do you tend to see customized agents built for each use case, or do you tend to see agent reusability?
Oh, sorry.
Oh, it's okay. So when you see for use cases, do you tend to see like customized agents per use case, or like small and run each time, or is it tend to see like across the enterprise, you have set agents for different use cases?
Yeah, so basically I would look at what my pipeline looked like, what I was trying to solve for, and then I would tailor my agents to that specific use case. So making sure that, you know, if I'm doing healthcare analysis, I've got the first one that's the orchestrator, maybe a director of that sort of role, and then each one under that would have a specific task they would normally do as a person, and then use that.
When you talk about agentic AI, do you have any plan to integrate that with the SQ protocol we're testing?
So MCP, yeah, this is fairly new for us as well as we haven't done a lot with that yet. We've still been focusing on our partnership with CrewAI because it's more developed. One of the big things I like about CrewAI is that it is it's more enterprise focused and has more stability than things like LangChain. Like LangChain is cool, like you can do a ton of stuff. But I've got buddies where they built out an agentic workflow in LangChain, and then 2 weeks later it was broken because they pushed a big update to it. So it's a fast developing solution where it's CrewAI gives you more of an enterprise size. Right, exactly.
I think that's all. Unfortunately, that's all the questions we have time. Yeah, thank you all for your great questions.
Absolutely.
Just throw it away.
Sure.
Is this on? Yes, it is. All right, round of applause. Give me 1 second. Hello, everyone. I'm Jack, and I'm going to give a talk that I poorly named React Meets Untitled. Does anyone know what RL stands for here? Anyone? What's it? Yes, reinforcement learning. Reinforcement learning is a branch of machine learning that is sequential. So
you have both mics. Oh, the color mic's got it.
this is off though.
Is it off?
Yeah.
Oh, maybe that mic's just a little thin. It's fine. Go ahead.
Sure. So let me just quickly introduce myself. I'm Jack. So I started my career back here in Chicago back in 2015. I was my first role was at Trump Club, which was sort of like the original Stitch Fix. If you could remember when there was a time when you bought clothes and they weren't through the mail. This was like a novel idea. Is this my best stuff or is this just me?
Yeah, maybe try a different one. Those are all busted. The 2 on the stand aren't good. This one, I think, yeah, works.
Is this better?
Yeah.
Can you hear me? Cool. All right, so let's rewind back to 2017. And I'm not just here to talk about myself. I swear this has to do with the thought. In 2017, I was kind of bored with software engineering, so I moved into machine learning. And at the time, I thought it was fascinating. I remember, like, the first time I understood how gradient descent works, So if you're familiar with that, sort of like the core principle behind deep learning or any like gradient-based optimization algorithm. Found it fascinating, and after a year doing that, was really into machine learning. And then I realized, well, this isn't as smart as I thought it was. I thought, like, these machine learning algorithms were going to be able to do a lot, right? And I'm like, well, it's really just like pattern recognition in like a little bit more of a sexy way. This is the way that I thought about it. And I thought, well, I want to see something like more interesting. Like I want to see some actual AI here. Like I didn't just learn all this stuff just to like do an image classification. So I made the bold decision to go back and get a PhD, but I wouldn't let go of my career, so I kept going. I did a PhD while I was working. So I did my PhD at UIC, and I studied reinforcement learning. And reinforcement learning, I thought this is the path towards actual AI, because reinforcement learning is planning, right? So it's not just I'm going to classify this image, or I'm going to guess what this stock price is going to be tomorrow. Reinforcement learning is I'm going to take the optimal sequence of actions. I'm going to optimize some plan or trajectory. Then fast forward, what is it now? 6 years, 5 years since I made that decision, and I come across this paper, React. It stands for Reason Plus Act. It's like a pretty famous AI paper. And if my guess is this is going to be foreign to all of you, so don't worry about actually reading this, but there was a part of it that stuck out to me, and I'm like, oh, this is just reinforcement. And I realized that, oh, this was not an accident. These people didn't just randomly choose the same notation that we all use in reinforcement learning. This was deliberate. And the reason for that is because you now have machine learning that can make sequential decisions with language models. And that is what we are all like now calling agents. Agents are things that can take a language model and make it useful in a sequential setting. You can make multiple decisions. So the reason I'm giving this talk is sort of like the end result of a bunch of thoughts I had after kind of merging these two things together. But let me quickly back up for a second and talk about how do algorithms learn? Because what I want to talk about is how do agents learn? But if we don't understand how just even more basic algorithms learn, then we can't really understand how agents are going to work. So this is like the typical MNIST data set where you're classifying images. Basically what it shows is that through a CNN or convolutional neural network, don't worry about what that is, you can identify images simply by identifying edges. So if you see these three numbers, all are, what is it, 5, 0, 6, they all have like the same edge there. And if you categorize all of these edges, you can easily detect basically any pair. So if you think about like, is like a machine learning image classifier smart? Not really, it's just identifying edges, right? So a CNN is able to detect edges. And despite, I don't know if anyone remembers this like whole AI wave back in 2018 or 2017 when image classification was huge and everyone was blown, like their minds were blown with it. Really, it's just edge detection. Like it's not that difficult. But after a couple of years, it kind of fizzled out, and now we're in like another AI boom. So I'm trying to kind of communicate like where are the limits right now, and that's where I want to go with this talk. All right, let's talk about reinforcement learning. This is if anyone's ever seen this mountain car problem, it's on the top right. Basically, it's this like toy problem in reinforcement learning where you're trying to get a cart up a hill, and you have to like use your momentum to get up it. And it's a good like test bed for can you come up with a reinforcement learning algorithm that actually can plan and make decisions. What it has to understand is like momentum or velocity. Like I want to build my momentum. And then when you train a policy, so it's sort of like in reinforcement learning you call a decision maker a policy, whereas like in machine learning you call it a classifier or predictor. But you train your policy to learn in what state, so in what position do I move left versus do I move right. And you can take a very simple approach, such as Q-learning, or actually policy grading is the same thing, where you just memorize, okay, at this point, at this position, I'm going to move left or I'm going to move right. And the way I'm going to figure that out is I'm going to try this 100,000 times and just guess randomly and see what works. So this is what I would call a dumb algorithm, right? It's just guessing and it's memorizing and it's taking advantage of the fact that it can just simulate this 1,000 times. So what are we learning here? We're just memorizing, right? We're not learning the concept of velocity or momentum. We need something more intelligent. So let's keep going. Let's talk about what do agents learn. I'm gonna make a quick aside here because when I like to discuss theoretical topics, I cannot understand something unless I see it in action. So I'm going to tell it like I understand it, like what I'm working on. So me and my team were working on this like recruiting paradigm where we're trying to figure out who is a good fit for what role. And before you all assume that what that means is just like automating recruiting with bots, that is not what we do. Recruiting is all about face-to-face interactions and selling candidates on the role. It's more like, I would say it's more like online dating than it is college admissions. You're not just like screening people. You're trying to find the good people and get them to come. So what we're trying to do is we're trying to figure out how do we optimize the right conversations to have. So it's all about, like I have this stat up here, which is roughly 2,000 engineers look qualified or look like a good fit. And not just qualified, they look like they would be someone who are interested in this role. Now, if you message all of them, you might get 20 who are actually interested in the good fit. But I don't want to message 2,000 people, right? If anyone's an engineer in here, how many messages do you get on LinkedIn? It's insane, right? So, and it's because basically everyone else is just using this like, very simple heuristic solution. So what we're trying to do is we're trying to figure out like, how do you optimize for this, and how do you do this in a way where you understand there's a trajectory of decisions you have to make. It's not just one, right? So if I am a bot and I say, hey, Jack, go message this candidate, they're a good fit. I say, okay, I'm gonna go message them. I realize that if this person responds, I'm gonna have a lot more decisions after. So that initial decision to reach out to a candidate has consequences, and you have to plan for that. Anyways, that's just a test bed that I'm gonna use to talk through stuff. Let's talk about chain of thought, which is it's not really an agentic framework, it's just a prompting technique. But we can think of it as sort of like a very basic agentic framework, I guess, where if we use it to evaluate a candidate, we have, so in this case, this is like actually a real person's profile, but I took the name out. This person works in trading, so works for hedge funds, Two Sigma and Hudson River Trading, and we put them through the system to evaluate them for a role with Chicago Trading Company. That is a real company, I swear. I don't know why they chose that name. They're actually a very good company. They're here in Chicago. But we evaluated them against this role to see, okay, are they a good fit for it? And if you know anything about trading, you have definitely heard of those two companies on the left. And you'll say, well, this person is definitely qualified for this position because those two companies are fantastic. However, what I know is that if somebody is working at Hudson River Trading, are they going to be a good fit for a Chicago Trading Company? Absolutely not. Because Hudson River Trading is probably the top paying company on the planet. Higher than OpenAI, higher than anyone else. Go on levels.fyi, then we'll, like, literally you make like $3 million as an engineer. It's insane. So what does that mean? Like, why am I bringing this up? Well, like, look at the prompts that I put in here. So are they a good fit for this role based on their propensity to obtain and accept an offer, right? So if I don't like really highlight that accept, or I don't like ask them to think about it more, they don't really take it into account. But you can, with chain of thought, just basically prompt them to think through it step by step. But are we learning anything? Not really, right? So chain of thought is basically you just tell the language model to think out loud. But the next time I come back, if I were to ask them to evaluate this candidate again, they're not going to remember to think out loud. They're not going to remember what the past decision was. We're not learning. We're just prompting them. Kind of similar thing with React. The paper that made me think of this talk is basically you're just integrating tools now, which is very cool. But it is simply now we are interweaving outreach with dynamic data lookups or other types of tool mechanisms in. And don't get me wrong, this is a fantastic solution. I love this paper, but you're not learning unless you hack it with RAG, which I won't get into. I'll skip past that example, but you can use React. You can use the React framework basically to dynamically look up information around candidates and companies to better evaluate them. But again, we're not learning. Now let's go to a new paper. Actually, this isn't new. This is also like late 2023, but it's like being discussed a lot more now. And this is actually probably my favorite paper that's been out in the last 3 years. It's this concept of reflection. And what it means is, suppose that, let's use the candidate example actually. Let me move on to that. So if we go to a candidate example and we want to review a past decision around, was this candidate a good fit for this role? We can say, okay, they weren't a good fit or they were a good fit, and we can explain why. that language model can take that information, remember it, and store it somewhere and bring it back up in a future decision. That's basically reflection. So reflection takes a binary or some signal as feedback, pairs it with its decision, and then infers where it made a mistake or where it did well. And then it remembers it for the future. So this is learning, right? Like we are now, every time we accumulate a new data point, we are making a better decision in the future. Does anyone actually recognize what this is on the right? Probably not, right? I have a 1-year-old son and he's obsessed with this reading along. Absolutely obsessed. And it made me, I thought of this because if you think about what I just described as reflection, which is like remembering corrective feedback, there's only so much that can do, right? Imagine, like, I don't know if anyone golfs here, but like imagine trying to remember all the corrective feedback about what's wrong with your golf swing and then like using it in your swing. You're just gonna mess up, right? You're thinking about way too many things. Same thing with this. She's trying to like walk like a man, and they keep correcting her to like change what she's doing, and she just looks like a lunatic. But in any case, it's similar to this reflection concept where, sure, we're learning by we're remembering what's wrong, but we haven't actually like changed our decision process, right? We haven't like made an update. All right, here's a better combo that I proposed that's probably being worked on or even published at this point, but I haven't found the paper yet. There's something called graph of thought, which is an extension to chain of thought, but more advanced, where you can use like predicate logic and more advanced reasoning, React integrated tools, and reflection with feedback. So there's a bunch of things where each of the, like where I highlighted that each of these frameworks kind of suffers or has limitations. Now you can package like the best parts of them all together to come up with something that can learn, can take corrective feedback, can update, can do like a gradient descent or gradient ascent like update. Definitely comes with some trade-offs, but there is a better approach out there where you have on the left two here. So we have graph of thought and we have React. It's like, what are we learning? What can we learn? And then this reflection of this feedback, how can we learn? How do we improve? So there's this concept in reinforcement learning called the reward function, which is how you take feedback and then update your decision process. So if you remember that mountain car example, where we're trying to get up the hill, every time we get to the top, we get a positive reward. Every time we don't get to the top, it's a negative reward. When we use that to then go and update our decision process, to modify our weights or whatever it is, to make a better decision in the future. So it's the same thing with any machine learning scenario where you have a loss function. Here in reinforcement learning, it's called a reward function. But in traditional like classification of machine learning, the loss function is usually pretty obvious, right? It's something like log loss, or okay, we have a binary outcome we're trying to predict. You can use log loss. We can say when the guess is correct, positive. When it's wrong, it's negative. It's really all you need. Reinforcement learning, it's pretty challenging. Like take autonomous vehicles, for instance. So if you want to build a self-driving car, you want to build a sequential decision model that understands how to control steering and hit the gas and the brake. Right? So you've got like 3 axes there. It's like 8 axes. So in any case, what is your reward function? Is it minus 100 every time you hit a pedestrian, minus 10 when you hit a car, plus 1 when you don't? Or what is that? How do you induce correct driving behavior just off of a reward? So the challenge here is like, how do we design a reward that actually induces the behavior that we want? In traditional reinforcement learning, usually you're just testing things out in some test bed where you have like, you can just simulate something like 100,000 times without much cost. And that's why you see like all these reinforcement learning studies done on things like Atari, where, okay, great, your algorithm works awesome on whatever that like rocket shooting game is, like, but who cares? Like that's not real. It's not helping anyone. And the reason they stick to that is because it's a closed loop environment with a very clear reward and very clear controls. But if you want to build a self-driving car, everything falls apart. Everything's much more difficult. You have to tailor it much more. And it's why most of this room probably is not super familiar with reinforcement learning, is because it's so theoretical that there's very few instances where it's actually useful. And the reason for that is because it's so difficult to construct that reward function. Like, how do you construct a reward that incentivizes what you want? So we come to what my PhD thesis was on, at least in part, which is inverse reinforcement learning. And this is an extremely complicated topic, but let me break down kind of like the intuition for it. Let me break down with this, first this self-driving car example, and then this weird psychology, not weird, but the psychology experiment. On the right, we have a self-driving car, I think it's what it was. Think about, okay, we want to train reinforcement learning algorithms to learn how to drive a car. Well, how can we do that? One thing we could do is we could put cameras and sensors in all of your cars, and we could let you drive for a year, take that back, and use it as examples to train an algorithm. And what we would do is we wouldn't say mimic this behavior to the algorithm. We would say assume that these people are optimizing some reward function. Now go figure out what that reward function is, and then go optimize it yourself. And when you do that, then you get something that's not only as good as drivers as you, but better. And so if you ever see those videos of these cars driving in like perfect unison, it's because they're optimizing a reward function that you cannot optimize because you're human and you have errors. Now we go to the psychology experiment. Okay, what does that mean here? It was the study back in like 2007, 2008, and it has nothing to do with reinforcement learning or even technology. But there was these researchers who were carrying books, and then they walked up to this cabinet, and they were holding the books, and they made it seem like they were trying to put the books in the cabinet. And these toddlers were in the room. There was always one toddler in the room at a time. And what they wanted to see was, what does the toddler do in this scenario? And I don't remember the exact numbers, but it was something like 90% of the time, the toddler, within 5 seconds, would walk up and open the cabinet door for the person. And while it's interesting, the reason I find it interesting, the reason this is actually often referenced in inverse reinforcement learning is you don't even have to demonstrate the successful behavior. You can just demonstrate an intent, successful behavior, and your algorithm can figure out what you're trying to do. Now, this isn't an actual algorithm, this is human, but the concept makes sense, right? Where if you demonstrate what you're trying to do, and you expose the right information to an algorithm, it can infer what your reward function is. So it's sort of like a way of bootstrapping. This is what we're trying to do. Go figure out a better way to do it, understanding that we can err and you have fewer ways. So if you think about this in the context of recruiting, we can bootstrap a reward function with, okay, these are all people who were successfully hired. These are people who were rejected in the first round because they failed the technical screen. You can basically provide it with a bunch of samples and then infer what is the reward function and then go optimize it further. So we as humans, like myself included, I review, I don't know, like 500 resumes a month. I probably make a mistake on 3% of those. This is my rough guess. An algorithm will make no mistakes, assuming, but it will optimize something exactly. So what I wanted to do is infer what I am trying to do, but then don't make any mistakes. All right, that was a lot, I know. And there's very dense slides, but let me try and like kind of pull this all together and communicate the point of what I want to say. When we're building algorithms, whether it's convolutional neural nets, reinforcement learning, agentic systems, there's a few things that are kind of like limiting or like control how effective we can be. The first is like our reasoning capacity. So how complex is the underlying decision-making structure that we're building? The more complex, the more abstract reasoning we can do, but the harder it is, the more data we need. Then what are the feedback signals? You know, if we're just doing a chain of thought, there's no feedback. We're just prompting them. So like, where are we getting these feedback signals from? And then last, how are we taking those feedback signals and then updating that decision-making process? So gradient descent is taking like a reward signal, using calculus to then go and optimize your policy or according to your loss function. But how we take that signal and update our policy is very important and oftentimes a limiting factor. That's it. Questions?
This is fascinating. And I was wondering, so with typical machine learning, when you're updating weights to the model, that's how you incorporate the feedback for what you should do or not. For an agentic flow, if you're like running LLM, doing this chain of thought, and then say you learn something, how are you then incorporating it back to the model, assuming you're not fine-tuning something? Are you adding it to the context? Are you changing the prompt, or what?
Really good question. And if I had like another 10 minutes, I would have gone through this in more detail, but excellent question. So like how would you actually go back and update this? So there was something that I kind of glossed over, which was this graph of thought. And so if you think about your decision-making process as like a bunch of nodes in a graph, one thing you can do is you can take that reward signal and go and update that decision-making graph. So you take, let's say that it's a candidate, and the candidate is like a bad decision for whatever reason. You go look at your decision-making process, figure out where it went wrong, and then go. So that's sort of like a language model-esque way of doing gradings. Good question.
So you said like for it to remember the feedback, it has to be present in a certain way that it remembers all the feedback that it's even gotten in the past. How is it doing that? And also how is solving for making the model like the black box that you're working with, like the changing the policy every time. How are you working on optimizing that too?
Yeah, so how does it remember cognitive feedback? So if we're doing reflection is, it literally just keeps like a memory buffer of a list of strings that is the corrective feedback. And that was like the Mulan thing that I referenced, where it's basically just like a list of like things that it's done wrong, and that's why it's super limiting. What I'm proposing in this line is sort of like an improvement over that, where we're not just remembering what we did wrong, we're actively updating the decision-making process right away, so we don't have to memorize this and like remember like how is this useful.
Just a follow-up.
Yeah.
But a lot of time your result function would come up very late. Like you wouldn't know the candidate is good fit at the same time. So what do you do with that flag?
Sure, we do the flag, so we wouldn't update it until we actually got the rules. So there's definitely one to do that. So,
Yes, I have a question about AI fairness and bias. So that recruiting example you had a couple of slides ago with inverse reinforcement learning. You know, it was making an assumption that if a guy's resume is from company X, then he's in some ways overqualified for this job in company Y, which is an example of AI making a subjective decision that might need like some kind of fairness, pane of glass explanation that the applicant might want to know about. What do you think about that?
Man, if I had an hour, I could talk to you about how to solve it. For context, my PhD thesis was on algorithmic fairness with inverse reinforcement. That was almost like a setup question. Fantastic. Really good point. So I'll start by saying that recruiting in general is currently unbelievably subjective. Like, I don't know if there's any recruiters in here, but I've been recruited the last 2 years and it's insane. It's absolutely insane. And the reason for that is not because they're bad people, it's because that is the nature of the system. That you have to take 2,000 candidates and figure out which 20 of those are decisions. So you take all the signals that you have and you make a bunch of known poor decisions, but lack of better option. But to your point, right, how do we explain this back? Because one of the things that this my company tries is that we are going to be biased, but we are going to be transparent about that bias and explicit. We're going to choose how and when we're biased. So we're going to assume, or if we're going to make an assumption, then we need to really get it back. So one of the things that we did, for instance, and I kind of glossed over it, but if you take the React part of this, which is the tool usage, you pull in these nodes or these data points that are useful to make a decision, and all of those are self-referenced in the output. So if you, for instance, say, okay, this is the reason why we rejected the candidate, you can actually go and trace back every single decision point for you. So I guess kind of working my way back to your question, how do we handle this fairness part? And we handle it through transparency. You're not going to say we will always be 100% fair, that we're always right. That's impossible. At the very least, what we can do, what we can guarantee, is that you will know why decisions.
I think we have time for 2 more questions. We have 2 quick ones over here, so take it away. Wait, did you hand off to someone?
I did, go ahead.
Okay, go ahead here.
Hi, so you had mentioned that you were reverse engineering the reward function for reinforcement learning, but doesn't that bring us back to the same point of like figuring out what the features are required for creating the reward function in the first place?
I would say there's kind of two parts to your question. There's like what is the reward itself, and then what are the features that are composed of the reward. When you do inverse reinforcement learning, you have to make assumptions about the environment. Usually it's like what features matter, and then you let the algorithm decide what the weights are. So a common example is you assume a linear reward structure with over a set of features, you let the algorithm decide on the weights. So in this case, it could be, how similar is their experience, what's the caliber of their previous employers, things like that. And then you let it decide. But yes, you're right, you do have to make that decision.
Yeah, it was a follow-up to the one about bias. So I know it's not necessarily the subject of your PhD, sorry. But from a legal perspective, that transparency is actually very risky. Have you thought about that? Have you shared that with anybody from that perspective?
So it's risky in the sense that if for the same set of features for a given demographic feature, you make a different decision. So we don't make decisions off of demographics, right? So that is not a component of what we do. So there's no legal issues there. Now, you can easily make decisions that are correlated with demographics without considering them. For example, if common with zip code, like you can make unfair decisions purely off of where someone like is born or where they're from. But that suffers no legal consequences. So I'd actually split that into two questions. One is the legality aspect, which is actually fairly easy to circumnavigate. The other is what is actually fair and how do you avoid that? And that's where you get into like equal opportunity constraints, where you condition on, you assume for all demographic groups, you condition on the people who are truly good and qualified, make sure that they are receiving the same portion of the essentially. So it's a constraint within the system. It also requires though that people communicate that information, which is challenging in itself. But definitely something for you.
Thank you, Jack. Everyone give Jack a huge round of applause. So we're gonna have about 15 minutes for snacks, food, have a little networking. But once you grab your stuff, kind of make your way back into this room because we're gonna kick off the last talk and the panel discussion pretty quickly after that. So yeah, grab your stuff, make your way back in, chat for a little bit, and then we'll get started again.
Glad I didn't follow you.
Those are both awesome. Thanks.
Thank you.
It's fun because sure.
So may as well do it now. Yeah, so we can pass it.
You're a popular guy. But I'm curious with skill stuff for sure.
Yeah. String. Hello. Okay, great. Let's start in our second half. So we're very happy to have Quentin from expert.ai, and he's going to show a demo of using Microsoft Copilot to build an agent. So here is Quentin. So
Hi everyone. I saw that given where we are today, we should try to bring together something more practical. So what I did today, or what I'm going through today, is going through Copilot Studio and how we can actually. Is that better? Why? Yeah, but I need to type, which is going to be difficult. So out of the box, Copilot Studio comes with a number of different agents. Unfortunately, they are not good for every use case. The particular use case that I was interested in was to determine whether I could create a solution that would enable me as a solution architect to do two things. Define a solution given a customer problem, and then do some level of competitive analysis to see whether I could find information about my competitor or people that are trying to solve a similar problem. So what I did was I started with creating a workflow, and hopefully the gods of live demo are with us today. They seem to be. So my chatbot is called Archie. And Archie is a solution architect that is looking to do something for us. So if we restart the agent, it should say that Archie is our virtual copilot to design solution that delights customers. Who doesn't want to have a chatbot that does that for you? It's kind of nice. I should point at this point that I added a number of different web pages as part of my knowledge base. you will see that we have the building AI agents as being one of the source, the GenAI collective, CrewAI, obviously. We've all heard about the model context protocol from Anthropic. That's another source. And I couldn't leave out, obviously, the documentation from Microsoft. That would have been a very bad issue, like trying to show the technology. So let's try with a very simple question and ask the system, what is agentic AI? Maybe he's going to tell us. At least it was working earlier, so hopefully it works again. So what it does, in this case, it goes to the knowledge base, which is all of the documents and sources that I have loaded. And in this particular case, sorry, Microsoft, it seems that Crew1 and CrewAI actually was the one that was used for providing the solution or the answer at the very least. And it says that agentic AI refers to artificial intelligence systems that are doing things by themselves. Kind of nice, but you use perplexity.ai, you use Copilot or any other tool, and you will get the same answer in one way or another. So not really helpful from that perspective. So one of the things you can do with Copilot Studio is you can start defining a number of topics that may be of interest. So what I did is I created a topic for CrewAI Enterprise Week, which is why we're all here. And essentially, I started telling it, if you get some of these keywords as trigger, you need to do a certain step or a certain number of actions. So let's say CrewAI Agentic. Agent Week. So in this case, what is going to happen or should happen is that instead of going into the normal answer as what we had before, which was answering the question, it actually triggered a topic, which I will show you in a minute in more detail. And if I take a problem that I used, because I'm not very good at defining problems, Google Gemini Pro 2.5, just to make it like that nobody is considered as not being inclusive. Because we have to be as inclusive with our generative AI as with other things. So let's make sure that we have a span of different things. So what I said is a customer needs accurate and relevant information, and it's trying to find these very in an efficient manner. Well, what I triggered as an action is to say, well, what type of things do you want to do next? If I click right now, competitive analysis or order, it's kind of going nowhere because I didn't set it up, and I will show you in a minute why. But if I say that I want a solution generation, which is creating a solution for the problem, what it's going in the background, it's calling a LLM with a particular prompt, and it's now giving you an answer. One of the things that I will say is that as much as this is very nice, and it's relatively easy to define your topics and define the flow, it's also somewhat difficult the first time that you're doing it. And the reason is that there are a lot of expectation, and it's not necessarily as intuitive as you would have thought. So for example, in this case, I created an LLM. First, I have a condition based on my choice. And in this case, is solution generation. And then it calls an LLM. And as part of the LLM, and I'm sorry for the time it takes, as part of the LLM, I give them instruction in a prompt to do something for us. This seems to be taking a bit too long. But one of the things is that you cannot necessarily control the information. And here you can see it's very simple in terms of the prompt. It's not elaborate. And one of the things that you also have to think about is that the actual process of having the response back is done through a topic or a message, and you can define like the information and how you want like to deliver the message, and you can control some of the information. Okay, so let's go back like to the prompt. I've not quite tested this before, so this is going like to be like really live. But one of the things that you can do, given the nature of the beast, is that you can change your prompt. You can adapt your prompt as you go along. So in this case, I can say that the problem that I'm looking for is the problem as an input, which should be sorry. Text. Choice. So I can easily change my prompt, so I'm not stuck to one prompt as opposed to another prompt. I can restart my whole process through it, and I can restart like the process of doing the interaction. Obviously, in this one case, and if I restart it here, it will give us back to the first interaction. I can again say CrewAI Agent, and it will ask me again for what my problem is. And you can see that in this mode, as you are writing the information in the central, or as you're testing, you are always have some level of explanation and transparency in terms of what is being triggered. So now I have done my solution generation, I've changed my my prompt, and technically I should have a different answer. And we do have a similar different answer. The formatting, again, is something that you need to work with as you go and use the tool, but it provides you with some of the information that comes through. So what I thought I would do live, and again, hopefully the gods are with us of live demos, is adding like an additional condition. So I showed we had 3 different options. We had the solution generation, competitive analysis, and then we had other. The way that it currently works as a starting point, I had whatever you were choosing for different options was going to all other options, and therefore going down the rabbit hole of essentially saying, yes, bye, and then it finished the conversation. But obviously, as we put in extra options to do something else, why not add an additional condition? We need to select the variable. In this case, we have to find what it is. In this case, we're going to take competitive analysis. And then we're going to add another prompt as part of this, which is part of our advanced. No, sorry. Share. To get yourself familiar with the interface, it's trying to be very minimal coding, like a lot of the new no-code visualization. But that doesn't, if you are very technical, it doesn't mean that it's generally going to enable you to give you the work that you want. So let's call this competitive analysis. And then we will have an input. In this case, our input is, again, the text, which is the problem. And we have, I've defined a simple prompt for this case, which is essentially to say that create a listing of features of competitor of offering similar solution that address our problem. And now I can save this. So now if I restart my agent, and again, CrewAI agent. I take back my question. And it seems that it. So I think this is a perfect example of what I was trying to describe, where it's not always intuitive. You're saying that you have defined like the variable inside of the LLM or the prompt, but when you look back into the application, you've actually not defined the actual input, and therefore it doesn't really process as you want. I think I got close to my 20 minutes.
Yeah.
So at this point, I will just kind of open it for questions, and if anyone has got any.
What's the profile of sort of the customer who will use Copilot Studio and Expert AI? Who goes in here and what templates?
So I would have deferred the question like to the people from Microsoft, but I will just take it from my perspective. I think as you're publishing this, it's actually available, or it can be published in your Teams. So you can have a channel in Teams that you say, this is my problem, and you start interacting with your chatbot. So it's really like you have a problem that your team like is facing like relatively often, and you want like to create a solution to enable them to solve that problem, that repetitive problem. You have a well-defined prompt that you know is going like to operate like very well. As you can see from this case, there is limited amount of customization that you can do like with regard like to the LLM module. You can't necessarily choose like, you have a limited range of LLMs that are available. So here you have the settings. You can choose like, in this particular case, like GPT-4o mini or GPT-4. So you are very much like tied to the Microsoft ecosystem from that perspective. I anticipate that over time they're going like to give more access to some of the models that you can deploy. You can deploy through Azure AI a large amount, of different LLMs and foundation models. It's just that in the current implementation, they're kind of limited to what you can do.
More questions?
Is it using like Landgraph kind of solution at the backend? Like...
That's a very good question. And again, like I will have to defer that to Microsoft, because it's pretty much a black box from the user perspective, in as much as they have made it opaque. So you have like the no-code user interface where you can define like your orchestration, which, as you have seen, is a bit static. You can integrate with the model context protocol from Anthropic, but right now it's very limited. So if you go, for example, and create a new action, which is something that I was trying like to do earlier, I'm not sure why it's trying to leave all the time. I probably need to save this. I think like from what I saw when I was looking at it today, there were about 10 MCP connectors that were supported. But they say that you can bring your own custom MCP. So if you have your own server, if you've got all of the different aspects and you have like deployed all of that, you can integrate it with it as well.
Anyone else? Maybe we can have one more question if there is one. No? Oh.
So I like to build AI agents too. What are the pros and cons of the Copilot Microsoft platform in your opinion?
Well, I think like someone mentioned it earlier, is that if you are in that ecosystem of Microsoft and you're using Azure for your LLMs, if you're using Azure for SharePoint, if you are using OneDrive, if you are using any type of data storage that comes, then it's the right thing. Because I didn't use it here. I did one internally for a company where I used access to SharePoint because that's what we use for the knowledge base. Obviously, being like an open demo, I didn't want to use our proprietary data. But I think like if you are in that ecosystem of Windows, then it's a very good solution. If you really want to have the control up to the API connector and all of that kind of things, there are a wide array of different solutions that are probably much better.
Thank you. And I think we have time actually for one more question. Anyone else want to ask something?
I'm curious. I'm curious. Do you be able to like cross paths like what Microsoft use if somebody has like no coding experience to like applications like Flow Code or like even other applications to like cross path?
Because you support MCP, you should be able like to support like cross-platform integration. But I didn't try to do it myself, so I cannot say whether it works or not, whether it's on their roadmap. Again, there was someone from Microsoft that was there in the room earlier that may be able like, to answer some of these questions. Just being like someone using the tool as opposed like to being part of Microsoft, it's very difficult for me to answer your question.
Thank you.
Thank you. Everyone give Quentin a big round of applause. That was amazing job. All right, so we'll get ahead to the panel discussion here.
I don't know if we want to have a quick intro, no? Thanks.
Okay, I'm gonna make sure this microphone works. I think that's pretty good. See anyone? Yeah, no safety chart here.
So it's first, yeah, you're either the first or switch it up.
Thought I'd introduce all of our panelists again. So let's see. It goes in alphabetical order by your last name. We have Mo Haghighi from Discover Financial Services, and Mo just moved from London to Chicago. So thank you for being here. Yeah. Okay. And then we also have Ari Kaplan. He's the head of evangelism at Databricks. So, and I met Ari in Bangalore. Believe it or not, we were both in Chicago. Yeah, that's awesome. Right. The first time. Big world, small world. That's right. Okay. And we have Dr. Reza Rooholamini, and he's the Chief Scientific and AI Officer, the Group Vice President at CCC Intelligence Solutions. And they do some great stuff in here. I went to their meetup. That was amazing. Well, you could do that. And now we also have John Stevens. He's the Principal Research Data Scientist, Generative AI Applications at AbbVie. So welcome, everybody. So, yeah. Let me show back up on my phone. Okay, the first question is not specific to agentic AI. Let's start by asking, how do the unique challenges in your respective industries, right? We have finance, we have insurance, we have pharmaceutical, and also cloud native data and AI product company, right? How do these, you have unique challenges in your respective industry. How does it affect your adoption and innovation, in AI in that area?
Yeah, I'm holding a microphone, so I guess I go first. So I work for AbbVie, which is a pharma company, biopharma healthcare company. There's a lot of challenges there because it's a very highly regulated industry, very tightly controlled industry. Just to give a couple examples, right? So one example, obviously, is the stakes are high, the risks are potentially high of using AI. So, we do a lot internally with AI. We have a lot of like internal facing generative AI applications for enterprise, which are more along the lines of employee productivity and just enhancing people's workflows, stuff like that. But it's a lot harder to, for example, get a chatbot in front of patients, right? So if you want a patient who is prescribed a certain AbbVie product, and you want to build an AI assistant to help them understand like how to take it better. I mean, that's a nice idea in theory, right? But putting that into practice is really, really hard because if you screw it up, the stakes are potentially really, really high, right? So it's a little different maybe than customer service chatbot, for a retailer or something where there's a little bit higher tolerance for error because people's health and people's lives are not on the line. And the second example is it's very tightly regulated. So one interesting challenge in pharma is what we call GXP, which is the like good practices, which are a set of regulations. And when it comes to building software for that industry and complying with those regulations, and this is necessary again anytime you're touching like patients' experience or anything else. One of the requirements is like consistency of results. So if you're building a piece of software that falls into that like regulated category, you have to be able to demonstrate basically like the same input will give the same output. Again and again, like the consistency is one of the dimensions that the regulators will evaluate against and you'll get audited for. So for those types of software, that's only one category of software, but for those types of software, you can imagine how difficult that is to build something with LLMs at all, let alone agents. LLMs never do the same thing twice, right? So I mean, it's sort of like, okay, I guess we could set the temperature to 0, but then what happens if we're using OpenAI and they upgrade to a new model and we have to upgrade, and then suddenly the responses are different. Do we have to run all of our tests again? Do we have to do the whole validation process again? So that's one of the biggest challenges that we have. And so we actually don't do a lot of that kind of GXP regulated stuff with AI yet. We're still figuring out, like the whole industry is still figuring out what does that even mean? Right? There's no playbook for it.
Well, for financial services, I can say everybody knows regulatory compliance and governance. That's the biggest issue. You've got so many standards that you need to be compliant with, and just using some black box AI model, it needs to be explainable and it needs to be transparent, for all the financial decisions made, whether you are doing some sort of credit scoring, sort of fraud detection. So that creates a little bit of delay in adopting, new models and be advanced enough, compared to the other industries. And then the next one is data security and privacy. Because if you look at banks in general, financial services institutes, they are multinational. They're operating in Europe, Asia, and other places, and there are data privacy laws in different countries, even in Europe, when you look at it. And for GDPR, for instance, so you can't actually have a system and AI agents that can basically go through all the customers' data in America and Europe. So you need to have like separate systems designed for different regions based on the regional sort of localized laws. That's another one. And I would say the next one is probably is just those legacy systems. Legacy systems. So a lot of financial institutions are trying to upgrade their infrastructure, and the biggest issue at the moment is for instance, you look at it from technical cloud adoption perspective, microservices model. They all need to kind of go through that model anyway, kind of adopting microservices architecture. A lot of them were quite against it in the beginning, but then we've kind of seen that Kubernetes is taking over. This containerization and orchestration is happening, and obviously using to adopt some AI models, you need to have that sort of microservices model in place in order to take advantage of AI with advanced models. So I would basically just stick to these three, even though there's a list of like 10 or more probably, but those are the most important ones.
Yeah, hi everyone. We see challenges all over the world, from Bangalore, way the road to Chicago, and everywhere in between. But yeah, common ones are companies just want to do these AI agents or chatbots on their own corporate data and governed. Like every industry we have up here, you can't send it out to some third party, ChatGPT for security privacy. So how do you, number one, make these agents based on your own data, then how do you have it all governed, and then how do you have it democratized? So like everyone in this room, based on the prior speeches, seems pretty technical, so there's some benefit there, but if you want to democratize to non-technical people, semi-technical, the business analysts, you're going to get 30 times to 50 times as many people in your organization getting benefit from your data. So that's like the other real challenge. And then data silos. Companies have all different structured data, the data warehouse, and unstructured data in the data lake. How do you unify it without having to spend all this money copying data back and forth? And then, of course, hallucinations is the big one. Talking to people on the breaks here, but from what I see, about 90% of the companies I've seen out there, when they do AI agents, it's like mostly internal based, since it's like ungoverned, makes up stuff, hallucinates. So, and only about 10% of use cases I see are external facing. So that's challenges everywhere.
Well, good evening. Good to be here. We have similar challenges. I mean, the governance is very critical. The accuracy is also important. And as you probably can imagine, any time a piece of software or anybody, even a human, make a decision how much money going to be passed from who to who, that's the fertile ground for litigation and so forth. So now we are in the insurance tech industry. We provide technology to the insurance company. So you can imagine that industry is very large, is very human intensive industry. And our vision is to automate and digitize basically the P&C economy. That's the property and casualty economy. A little bit about our company. We were incubated in Chicago almost 25, 26 years ago. Our revenue is a little bit south of $1 billion. We have almost 350 of the large insurance corporations as our customer. Our IP is really our network. We have 350 plus insurance companies on our network, close to about 1,200 parts suppliers, 30,000 repair facilities, and the network grows. So you can imagine, as an example, we have developed a fully automated, mainly computer vision-based solution, such that if you get in an accident, take your phone, take a few pictures, or do a 360 video, tell me what you see, and we will generate in a matter of 2-3 minutes what we call a Lambda estimate. What is wrong with this car? What needs to be done to it? How much it's going to cost, and so forth. Now, this function currently happens where it's done by humans. People are sitting in a parked car going around and visiting 4 or 5 cars and writing estimates for those damaged cars. But therefore, having such a large industry with so much human intense or involvement, trying to digitize that, then there is the issue of the change management. How do we make that industry adapt and adopt the technology? It's not an easy job. And I could go through much more detail of how we're trying to tackle it. So basically our challenge is certainly we are highly regulated. We have National Association of Insurance Commission. That's one major entity governing how the insurance companies operate. Every state has Department of Insurance. They have their own mandates, compliance, and then the federal government, consumer protection agencies, and so forth. So we are subject to a lot of compliance basically policies that we have to abide to. As I indicated, if I create an agent or a piece of intelligent entity based on AI that can decide how much the insurance company got to pay to this client whose car is total, that is an example of one transfer from one person to the other. Now, if AI decides that, that's a further ground for litigation. Believe me, there are no pun intended for our legal colleagues, but there are lawyers that waiting to basically take the process through the litigation. So we have, therefore, we have to be very careful. We have invested quite much, probably even more than the amount of investment we have done to create this solution on the governance. So change management, naturally governance is very critical. And then, of course, internal cultural change as well. I mean, developing these solutions internally, that also has some challenges, making sure we have the right people, we have the right mindset, we have people with the right tools in their toolbox, and so forth. So these are an example of some challenges.
That's great. Yeah. Michael, would you like to?
Yeah, so kind of getting beyond the sort of enterprise level and, regulatory governance challenges, getting more to the technical side, like what are the use cases that you see, that are within the reach of agents right now that you think have a lot of value, and what are the ones that, maybe are going to take 5-10 years for the capabilities to catch up? Or, I don't know, at the pace things are going, like maybe a year, but 6 months,
That's like dog years, right? 5 years.
Yeah.
It's still like 6 months. But so let's get what are we capable of right now with agents? What are we doing? What are we trying to do? I think the two big ones on my mind, and I know there's more, but if everybody loves deep research, right? I'll use like Perplexity or which has to do deep research. And one cool thing is for enterprise is the idea of that, but plugging into all of your company's own internal systems, databases, and things as sources for that research instead of just using the bot, right? And the other thing is content creation. And that's a big one too, right? So what I imagine, and this is something that at AbbVie we have kind of the building blocks for, but we haven't pieced them all together yet. But if we had an ecosystem for agents that we could, with agent interaction protocols and things where we could pipeline these things together really easily, you can imagine, like, let's say I'm a scientist and I want to monitor scientific literature for research on a particular gene or a particular type of therapy, right? And so I might have one agent that just monitors that and then triggers like research reports over any new ideas that happen in that space, right? I might have a second agent that takes that and like finds all the adjacent topics and web of research around that and generates does a deep research over that from all the literature databases. And I might have a third content creation agent that could take all this, formulate it into structured documentation or PowerPoint presentations or even AI generated podcasts. So then if you string these things together, you imagine a world where I just register what I'm interested as a scientist, and then boom, one day in my inbox pops a PowerPoint deck, PDF, and a podcast MP3 about a cool new thing that I should know about as a scientist. So that's kind of the now part is like we have the building blocks for that. The 6 months part, because I have no idea about 5 years, is putting it all together and really truly automating all of it. So making it all like actually agent.
For financial services industry, I would say fraud detection is the biggest one at the moment that AI agents are helping a lot. And the adoption is massive. If you look at every single player in the market, they're doing as much as they can just to reduce costs and losses. So given that AI agents, they need rule-based, structured, data-intensive, and API access, data pipeline. And for fraud detection, that's kind of already there. So the agents already have that sort of access, and they can easily just start kind of processing data with respect to some of the social media sentiment, to behavior of the transactions, the anomaly detection that happens deep down, and they're doing a great job. But I wouldn't call it as a multi-agent system. It's actually doing a great job. As a single agent, each one of those kind of tasks is done properly. But again, you need humans to kind of connect those dots together. So they're great to augment the decision-making process for humans when it comes to fraud detection and reducing those false positives. But obviously, in a few years' time, I can definitely see that's happening. The multi-agent system, all these agents. But that requires a lot of work. For instance, that interoperability. I think you mentioned that that lack of those silos are killing them, because all these financial institutions, they need to work together. They need to have that sort of model in place where they can share data with all those access controls in place, and again, regional laws and everything else. And that's not happening. Some of that I think is on purpose because of competitive reasons, they don't want that. But some of the other ones are actually technical challenges. And again, I try to look at it from the clouds and API perspective. From the technical perspective, if all of them try to modernize their platforms, that definitely becomes a possibility pretty soon. But again, that modernization journey is huge. Like you've seen so many companies kind of facing a lot of hurdles in the process because a simple application in financial services, that's about 200, 300 microservices, and just like bringing that coordination between your microservices, between your teams, product teams internally, that's a huge challenge, let alone having that sort of kind of coordination and interoperability with other firms. So fraud detection is actually happening perfectly. I would say not perfectly, but it's getting very close to that perfect model. And then portfolio management, like investment management, that's actually something that I've seen a lot of good work in the area and a lot of good results. But again, there's so many outliers as well. You suddenly see like, wow, what's that? So those black box decisions sometimes surprise you, but they're getting better and better with that sort of historical data. So those are the two that I would say probably are the top ones. But again, internally you can look at developers and how much you are basically helping developers to optimize their workflows, programming, it just is helping developers a lot to refactor those legacy programs, and that's quite important.
All right, well, maybe I'll do this in 3 parts: past, present, future. So my favorite agentic case, maybe before AI, but towards it, I created the Chicago Cubs analytics department, and we use agentic-like systems for evaluating players, evaluating mechanics, structured, unstructured, human, like what do scouts say? So
evolved from here.
Partly. Yeah, and so that worked out well, and then joined Databricks, and I didn't really introduce the company, we're a leading data and AI company. Up until this week, I was telling people we were the highest valued private tech company in the world, we're the single largest fundraising a few months ago, 10 billion, and then OpenAI just got like about 30, 40 billion a couple days ago. But yeah, they're one of our larger customers. But for this audience, like there's so many different really cool agentic use cases now, and to be honest, it's really just getting started. Like that term, I don't know, like late last year started popping up, but the systems around that, have always been fundamental. From Alteryx, a company I worked at called Data Robot. How do you automate and join different processes? Some could be AI, some could be non-AI, some could be a human in the loop, like you mentioned. But yeah, some of the more recent ones that I love, I was just in Finland. I love video games, Supercell, Clash of Clans, Clash Royale. They have they said over 1 billion humans on Earth played their video game at one point or other, and they use agentic systems for before you play, who are you matched with? What is toxicity control? Like as soon as someone's about to start cursing, like they can cut them out right away, but in-game, advertisements or upsells, that was a cool one. Maybe I'll save some if you're talking about ROI later. But I don't know, Disney Plus is a cool one. They have trillions of records being made every week. But how do you do things real time when you you like this program? How about liking that program? But I realize you're a household where 2 spouses and 3 kids may have different needs. But so that's agentic. Who's watching? What was most recent? What's new? When you use the remote control, it does kind of listen in on you, but how do you use AI to see the background noise, what language you're talking, real-time use cases. And then in the future, 3 to 5 years is super hard to say. Hopefully we'll be learning on Mars or something, but I hope self-driving, that type of autonomous will be incredible. That's really future, but for information, yeah, every single like worker-based economy where you're making decisions, that's kind of where the world is almost at right now. I'm on the Intel board of advisors, so just this morning I was out in Vegas and they were showing different, cases of like fabrication facilities, not theirs, but you're manufacturing a car, and you can see where the problems are real time. How do you optimize like humans going in and out? But I don't know that's where like, and then this is called RPA, robotic and process automation, which is precursor to this. Some of the challenges are it mirrors keystrokes to do things like download these 5 data sources, merge them, make an Excel file, and email it to someone. But then if a pop-up window pops up, it'll throw the whole thing off. It'll pop up, buy this popsicle. You have to hit that X. You still need to have these agentic systems fixed for like snafus of the real world. But the future is amazing. I can't wait.
Just allow me to be a little more specific in the line of business that we are in. I'm really excited about the technology. We develop basically solutions, it's automated solution, what we call for the industry. We use 350 plus insurance companies, data, accident data, claim data, and we create basically an automated process. The processes that happen in these insurance companies, for example, processing a claim on a damaged car versus a claim on a damaged body versus a claim on a property versus writing a policy. These are examples of workflows. Now, a given automation doesn't apply to all of these workflows. They have different steps, different number of steps in the process. Now, on top of that, we have 350 such customers. Not every one of them uses the same workflow for processing a claim on a damaged car. They have their own steps. They have their own process, their own workflow. So there's 2 layers of diversity or changes as I develop a solution for what we call an industry solution for processing damage on a claim on a damaged car. There is multiple instances of that need to be created, one for each insurance carrier, because they don't practice the same process. So agentic therefore has great role here. I can see where if I develop these workflow automation based on key steps as an agent, then those agents can be replaced with basically an agent which is more suited to this company, maybe with another one suited to that company. So I can basically create a foundation that can very easily be adapted, adopted by a given workflow within a given company out of the 350 that I have to support. Versus today, without the agentic, when I develop these workflows, I put 250 or so knobs, for example, such that when customer X want to adopt this workflow, we go through the process of setting these knobs at the different levels such that the system produces a result which is more in line with their culture, their desire, and so forth, like tolerance to loss on one claim, maybe getting a little bit more money on the other claim. That's a cultural shift. So in other words, I adopt this industry solution to a given culture of a company with these knobs. Tomorrow, I can do that with the different agents. I can have these simple agents that can replace a step in the process to automate or adapt the workflow for a given customer. So you see, that is one of the great examples of how we can potentially use the agentic or agent-based solutions to adapt and make these workflows more customizable.
So we are technically actually just a little bit past time, but I'm sure there are plenty of great questions from the audience. So why don't we just go to the audience for the next part? So we only have one good mic. I would say just kind of shout it out loud and we'll read it. Right there, in the back. Or okay.
Yeah, thank you. So I have just left Accenture, where I was the Midwest Ventures lead. And one of the things that was important to me, the second I saw ChatGPT come out, I knew that the generative AI agents were just going to be simply the future. And so I work with a lot of companies. I don't know if I'm allowed to say that, but maybe one of the ones up there. And I hear a lot about how slow it is to deal with regulations and GXP, and I experience the same thing. But I would be interested to hear at what point does the people and the people we're serving become more important than that? I say that because, we keep trying to fit these agents to these existing legacy processes. Most of you, I know everybody in drug manufacturing knows that a lot of those processes shouldn't be there and they slow people down. And, one of the things that inspired me to start a company was my mom dying of cancer. And it's because they misdiagnosed her with diabetes. And that's something that, I'm sorry, at Microsoft, but Gemini 2.5 has done a better job of looking at her case and making a better decision. So at what point are we going to prioritize bringing the best innovation and solving these problems for human beings versus talking about archaic regulation and how that's stopping us from making progress?
Yeah, well, first, very sorry to hear passing, and the hope is that, yeah, all of what we're doing will help humanity more than hurt it, and healthcare, misdiagnosing is, terrible. But, that's, coming up with cures, that's one example. Making better medicine, making better, claims and everything like that is going to be incredible. But, with the movie Moneyball, that was like one of the themes is, since you've been doing something 100 years or 125 years, sometimes, yes, that is the best way to do it. But I'm a big proponent, like first principles, maybe the way we do healthcare or education or government or I don't know, pick any industry. For some reasons, yes, maybe that's exactly the optimal way, but there should be points in society where you just think, how can we just like rehaul either industries or the way people do actual work? Like I'm old enough, my kids are like, wait, when you were younger, there was no like cell phones, and how did you bring work home if there's no internet? And that took a whole re-innovation of society.
Yes, as you mentioned the healthcare industry specifically, I think there is also the reality on the ground that I think if you were to pluck 10 random people from 10 pharma companies and ask them about this, they would all agree with you that I think we want to create a world where it's the outcomes that matter and not the processes, but at least one of those 10 people is going to be like, yeah, but if we get audited, we're totally screwed. Right, so there's the reality on the ground that like the FDA will come in and bring a hammer down on you if you don't do things their way. So the problem is that the regulations and the rules have to catch up to the new world that we're in, and I'm sure that they will. It just takes time, right? So there are certain rules and regulations that made a ton of sense back in 2005, in 2025. It's not working, right? But so that change has to happen like industry wide. But I mean, in like philosophically, yes, I think you're absolutely right.
Thanks. I just have to leave, but thank you guys so much for coming here and doing this. And, despite the criticism, like it's only because I believe companies like AbbVie are saving lives. And, I've met some of your people that have created medicines that, people wouldn't be here anymore if we weren't able to do that work. So all I ask is that, the next time somebody makes you afraid of an audit, just think of all the people that you've helped and that you've saved and that you've made new and amazing lives possible. And I think maybe that should be, just a priority for us all. I have to head out, but thank you guys so much. It's a pleasure being here.
Appreciate it.
Thank you. I mean, as an AbbVie employee, like that really means a lot. And that I'm really sorry that you had to go through that, but hopefully, we're working every day to make sure that happens to as few people as possible, and just we want to make a better world. So I really appreciate that.
Of course, thank you.
Glenn?
Yeah, everyone has been speaking about hallucination, and I find that when we use the term hallucination, we're speaking about a bug. Unfortunately, it's not a bug, it's a feature. It's core to the way that it's predict what the next token is. So do you really think that it's a problem with regard to the existing regulation, or is it a problem with the AI literacy that people are trying to leverage a tool that they don't necessarily understand, and therefore fear because of the risk that is coming out. But if we were teaching them what it's actually doing, we would actually resolve the problems.
I'll be really quick. I think you know it's a problem with the others. Every time somebody says, they give us feedback on our system and they say, I don't like this because it hallucinated an answer. And it's sort of like, that's a failure of AI education because it's like you should expect. It's sometimes false, right? There's a certain hallucination rate. So it's not, don't file a bug report if it hallucinates once in a while, right? So I'm exactly with you, but it's a change in thought for the users, right, to understand. So I think that's where that.
Great question. I mean, in our case, there's really two classes of things that we've got to keep an eye. To your point, if you do the RAG or train the model with your stuff and so forth, so that kind of hallucination would go away. But the other factor that we have to be concerned about is that whatever AI produces is not the exact science, it is a relative. Because our models, for example, when they detect that the part is damaged, they provide the accuracy of 90% sure that this part is damaged. So we have to deal with that kind of inaccuracy as well, or relative, or not deterministic behavior. So that's the second class of sort of, if I may call it, hallucination that we have to deal with.
Can I just add that
Sure.
there is no way that generative AI as it is today can actually do a score. Because it's just about predicting the next token, not about predictive analytics. So I think like when we come with a score of saying like it's 90%, where does that 90% come in terms of the black box that you're actually sorry.
If I may just make one comment to the previous question, we serve the insurance industry, but think we go through these unforeseen accidents or events in our life. We get in a car accident, it really dismantles the day and so forth. So we also have, there's a little bit of human aspect of what we do as well. We want to make sure the person gets back on the road as quickly as possible in a safe way. We're providing what is needed to basically make that incident as pleasant as possible. Because if your car has to be in a shop for months, or you don't know what's going on, if you don't get a rental right away and so forth. So there's a little bit of what we do as well. There's a human aspect to it as well, helping the humanity, helping the experience of these bad events that happens a little bit less painful.
And I think that's like an awesome incisive thought, that the word hallucination is just one, like there could be, it's what the program is telling it to do. But I think what it comes down to is people who are trying to get information, is it the right information that's accurate for what they're looking for. So I priorly mentioned people want to do insights on their own data, which is a challenge, but they also want to use their own linguistics and context. So baseball, deceptive is great. You don't know where the pitcher's arm's going to be, but in finance, deceptive might mean fraud or something like that. So what's the language of what you're looking for, which is why the concept of AI agents, where you have smaller, whether it's LLMs or some other capability that is very good at predicting traffic, weather, reasoning. So that is one part that the world needs to. And then the question I always ask, wherever I go, is like, how do you measure how accurate whatever it is you're looking at? Traditional machine learning, you have like R squared, log loss, Gini norm, which is an actual number, where you can say this data fits better, than that model to the data than the other. But with LLMs as the premier example, it's like a gut feel. You have all different things like third grade reading level or 12th grade reading level, but that's not applicable everywhere. So just one example, and I know there's a question there, pass it on, but like for Direct, did this really, I think this died out. All right, so for Direct, if you can hear me, yeah, they had a chatbot that they gave their agents, like their 1,000 agencies. All right, so yeah, for Direct, great use case, but I asked them, how do you measure how successful this external chatbot was? They were one of the few companies where it was not just internal, they let non-technical dealers who are reselling Ford products, go, and it was just, they did a survey. How helpful or accurate do you find the information? And it was 95%, which was the best. FactSet, 87% was the next best. And then another point with hallucination is, that's a bad word, but you also, from your company, wasn't Ford Direct, it was a competitor, I forget which one it was, but made famous in the press, where somebody asked, what is the best pickup truck? And it was like, oh, the Ford F-150, which is an opinion, but technically from the algorithm was true, and it said, on their website, our competitor's pickup truck is the best, and people kind of laughed at it. It's not a hallucination, but companies want a guardrail, kind of pull and push the answers.
Let me add just a quick point. So there's a ton of work actually happening with RAG, since Reza mentioned that, to kind of reduce that hallucination. And again, when you look at it from the multi-agent perspective, now they're basically, if you look at some of the academic, work coming from academia, they're designing multi-agent systems that agents are vetting the other agents just to make sure with all the quality gates and all the thresholds that are put in place, they want to make sure that the outcome is something that is expected, at least within that sort of, decision tree or whatever, that sort of framework is. Within financial services, I can tell you that I've never seen an AI agent actually making the decision or doing the whole process on its own. It's always about augmenting, human beings. So basically, we are now at a stage where AI agents are automation assistants, and we are kind of moving towards that sort of phase where they're going to be the autonomous decision makers, but that hasn't happened yet. And the same goes in healthcare, basically. Doctors and surgeons are taking advantage of AI a lot, but they never actually leave it to the AI agents to kind of implement. I was at UCLA Health last week, and I was absolutely amazed at all those telemedicine and kind of helping surgeons to run, to do the operation remotely, and it was just amazing how they could actually kind of adjust the pressure on the skin, 5,000 miles away from the patient, and kind of do that stitching process. It was an experiment, but the fact that the AI agent could actually predict the latency in order to make sure that the surgeon is actually feeling the that pull and push force exactly the right way. That was just amazing. They were using a lot of data from different hospitals over the past few months. I mean, we are getting there, but that hallucination actually with all those gates and thresholds, I can see actually is getting reduced massively. And again, they're using reinforcement learning, RAG, and so many other things around it. Those are experimental at the moment, but they've been quite impactful and effective so far. That's honestly, yeah.
Yeah, thank you. That's great. Great answer and great panel. We are unfortunately about 15 minutes over time, and the Microsoft people want to go home at some point. So basically, huge round of applause for our panel. Thank you. I'm sure there are a lot of other great questions. You do have them. Definitely encourage you to catch up after the catch up now. We have some food left. We have some. I hope we have some booze left over. I'm gonna go find some. But we have space for about another 20 minutes or so. So feel free to mingle, hang out, have a snack, and thank you all for coming out. This is a great event. Really appreciate it.
Thank you.
Stabilized, got some steady clients.